In these videos, I'm going to try to describe how I learned about astronomy. I have no formal training and I'm not a teacher, but I do have a passion for the subject. This will not be a comprehensive or even conventional video series. What I mean by that is that I will be covering some very basic concepts as well as some more advanced subject matter. There are many other videos on YouTube which go into great technical detail and complex mathematics. I will try to keep things reasonably simple and connect them to things everyone can relate to, wherever possible. When I was a kid, I lived in a big city where the light pollution meant that on a clear night you couldn't see that many stars. Sometimes we went on a family holiday and stayed in a cottage in the country, far from city lights. On a handful of occasions I was amazed by the beauty of the night sky and got a sore neck from looking up for so long. Through my binoculars, especially if I steadied them against a tree trunk, I could see so many more stars between the ones I could see without binoculars. I wondered how far away they were, whether they moved over time, which ones were planets, and so began my interest in astronomy. The closest astronomical object to us is the Moon. It is very familiar to us, but how much do we actually know about it? It's a huge ball of rock which orbits the Earth at over 2,000 miles an hour once every 27 and a bit days. It is held in a stable orbit by its motion and gravity. I'll come back to gravity and orbits in a future video. Everyone is familiar with the phases of the Moon. As it orbits the Earth, a different part is illuminated by the Sun. From the Sun's point of view, the Moon is always full, but from our point of view, the phases of the Moon repeat every 29 and a half days. This is different from the 27 and a bit day orbit because the Earth-Moon system is itself orbiting the Sun. The speed of our orbit around the Sun is much faster than the Moon's orbit around the Earth. So if you were observing from Mars or somewhere far away, you'd see the Earth-Moon system whizzing round the Sun at about 66,000 miles an hour, which is about 25 times faster than the speed of the Moon orbiting the Earth. How far away is the Moon? To get an idea of the relative scale, the distance is approximately 30 Earth diameters or 110 Moon diameters. The distance is about 238,000 miles, nearly 250,000. The average car will probably drive less than half that distance from the showroom to the scrapyard. Between 1968 and 1972, 9 NASA Apollo missions went to the Moon and back, and it took them about 3 days to go each way. In 3 days, the Earth-Moon system travels about 5 million miles around the Sun. That's about 20 times the distance from the Earth to the Moon. So although the astronauts were traveling as fast as they could relative to the Earth and Moon, they were traveling much faster relative to the Sun. Try to remember this concept. I'll be coming back to it in a future video when we tackle Einstein's theory of relativity. So now we have an idea of how far away the Moon is and how it is moving. What about the size? How big is it? Well, the diameter is 2,160 miles. Not that different from the size of Australia. It is just over a quarter the diameter of the Earth, or 3/11 to be more accurate. The Moon is ever so slightly pear-shaped, and I mean slightly. It's as round as a billiard ball, but the bulge is enough to keep the same side facing the Earth. The mass of the Moon, or its weight, is about 1/80th that of the Earth. Although I've said that the Moon is orbiting the Earth, it's more accurate to say that the Earth and Moon are orbiting each other around their common center of gravity, the barycenter. Because the Earth has 80 times more mass, the barycenter is within the Earth, but not at the center. The Earth has the largest moon in the solar system, relative to itself. There are larger moons, but they are orbiting the gas giants. But more about them in future videos. There are several theories about how the moon got there. One of the most plausible is that early in the life of the solar system, probably more than 4 billion years ago, the Earth and another planet collided, and the resulting debris coalesced by gravity and its motion into what became the moon. It used to be closer to the Earth, and is moving away by just over an inch per year. I can't explain the exact reason for this, but I believe it has to do with the frictional effects of the tides. I mentioned before that the mass of the moon is 80 times less than the Earth. You might think that the gravity is 80 times weaker, but this is not so. If the moon were the same size as the Earth, but the mass was still 1/80th, then the surface gravity would be 1/80th. But because it is 3/11ths the size of the Earth, the gravity is about 1/6 as strong. The Apollo astronauts, despite their heavy spacesuits, were able to jump higher than they could here on Earth. Personally, I would love to go to the moon one day, to be able to jump 6 times higher, and also to be able to look back at our home planet. In a possible future lunar base, the Earth would always be visible in the same part of the black sky. The stars would not twinkle, as there is no atmosphere to distort their light. The lunar day is a fortnight long, followed by a cold, dark 14-day night. This could take a while for humans to get used to. One thing I would like to see NASA or anyone else do is to set up a lunar observatory. With the lack of atmosphere and slow rotation, I'm sure we could learn a lot more about the universe. However, I'm sure there are good technical reasons why this hasn't been done yet. If anyone has any astronomy-related questions, please let me know, and that may have an influence on my future astronomy videos. Thank you.